Hello everyone, Bongani here from Song Survey Instruments. Today we are out in a solar plant construction site where I will be showing you how you can use the Emlid Reach RS4 Kit to set out infrastructure like panel rows, inverter stations, and cable routes. The Emlid Reach RS4 Kit is a high-precision GNSS receiver that allows you to collect points and place point from the design plan. So I have already turned on my Base and Rover. Now I'm going to show you how you can configure the RTK setting between the Base and Rover, create projects, import the design, do the site calibration, and stake out the points from the design. So the first thing first I'm going to do is to make sure that my Bluetooth is switched on. Then I'm going to go to Emlid Flow. On Emlid Flow, the first thing I want to do is to connect to the RS4 base. As you can see that I've already connected, there are mainly two things that I want to focus on. I need to make sure that the base is transmitting the corrections to the rover and it's also transmitting an accurate positioning data. So I will first go under base output. As you can see already, my base output is set up at LoRa radio at 869.4 megahertz. So I am transmitting corrections of LoRa radio at 869.4 to the rover. Under the base setting, I need to make sure that the base position has been averaged to average singing because I'm going to be doing a base shift or side calibration. So I'm going to make sure that it's already averaged. Then I'm going to go back one. The next thing I'll need to do is now to connect to the rover. So on the same tab, I'm going to go and tap on the RS4 Pro Rover. So what I need to make sure on the RS4 Pro Rover is that under my correction input, I've set up the same LoRa output that I did on the base. But then the base output, I need to make sure that it's absolutely off. So you can see under correction inputs, I'm already receiving LoRa corrections at 869.4. And if you can check at the top of my right screen, I have already gotten a fix. So once I have the fixed solution, it means that my base station is sending out the correct corrections to the rover. The next thing that I will do is to create a project. So I will move from receivers to survey, and then I'll go on the plus sign, and then I will give my project a name. So my project name will be Design Stakeout. And then the author is Bongani. My description of the job is setting out. And then I'm going to choose my coordinate system. So I'm going to go under coordinate system, type HART for Hartbeeshoek to appear. And then I'm going to click on Hartbeeshoek LO21, which is the coordinate system that I'm located on. And then I'm going to make sure that my vertical datum is also selected as the South African shield. Once that is set up, I'm going to go save. And then now my project has been created. So the next step now is to import the design. So I'm going to go on the bottom left of the screen where I have an icon with 3 dots and 3 lines. I'm going to say import. I'm going to import a CSV of the design. I'm going to choose file. I'm going to go under Android where I've saved the file. As you can see, I have solar plant there. Click solar plant and my 12 points has been imported. So after importing my design, the next step is to do a site calibration or the base shift. So what is very important is that you must have the benchmark at hand. And I've already set up my benchmark. So what I will do is I will go physically measure that benchmark and then do the base shift. So I'm going to go plus sign. I'm going to make sure that my height of the pole is set out at the correct height. At the moment, my pole is set up to be 1.8. I'm going to save that. Because I'm dealing with the benchmarks, I don't want to instantly measure my points, but I want to average my points. So I'm going to go on settings, make sure that my settings are set up to average under collection mode, and then I'm going to save that. So once saved, I'll have to walk to the benchmark, measure the benchmark, and then do the base shift. So now that I'm on a point, I'm going to call my benchmark BM1. Then I'm going to give it a suffix or a prefix because I already have a BM1 existing. So I'm going to call this BM1 measured. And then from there, I'm ready to measure. So I'll make sure that my bubble is centered. I'm going to go measure. Okay, once measured, I'm gonna go back 1, and then just below the plus sign there is a grayish arrow that I'm gonna drag up. Then I'm gonna go under base shift, because now I've measured my point. I want to do the base shift or side calibration. So I'm gonna go under base shift. The measured point will now be the BM1M, which is the one that I measured, and then my known point will be BM1. So I'm gonna go on the design and look for BM1. Then you will see that there will be a calculated shift, and then I will press apply. So once applied, I will want to stake out my BM1 and then stake out another independent point to show that my side calibration has been successful. So I'm gonna go on the list. First, stake out BM1. Make sure that I'm centered. As you can see that I have good residuals for BM1. The next thing I will do is go back to the list, choose an independent point for stakeout check. So in this case, I'm gonna choose PR1. I have good residuals for PR1 as well. So now that I've checked my work, now I'm happy to stake out the whole design. So I'm gonna go back 1, and then from the design I will proceed with PR2 and stake out all the other points that are on the design. So I'm gonna go on the list, choose PR2, and then say stake out. So when you are staking out, you need to make sure that you are always facing the north. Then from there it's easier for you to navigate, because you will do the opposite of whatever that the screen is showing you. So at the moment the screen is showing me that I'm 2.5 meters south of the point, and I'm also 0.2 centimeters west of the point. So now this means that I will have to go north 2.5 and go east 2 centimeters. So now as you can see that I'm on PR2, I'm going to measure my stakeout so that I can generate a stakeout report. So now this will help me to compare what the design was and what I've collected on site. So I'm gonna go measure. Then I'm gonna go to the next one. So in this case now, because I'm already staking out a design, I don't have to go back to the points list again. I can use the arrow here just below the residuals, either use the forward arrow or the back arrow. So in this case, because I'm going forward, I'm going to use the forward arrow. So now I'm going to be sticking out PR3 and so on. Going to center my bubble, and then if I'm happy with the residuals, I'm going to knock in the pin, then measure. Move to PR4, which now I'm using the forward arrows. I'm going to look for PR4, knock the pin, then measure. After measuring, move to PR5. So looking at the north, that's how I will be able to navigate. I will level. If I'm happy with the residuals, then collect the point. Move to PR6. Look for the point by leveling my bubble. If I'm happy with the residuals, then measure. So this is what I will be doing until my whole design points is collected. Now that I've done setting out my point, the construction team can continue. This is how you can use the Emlid Reach RS4 Kit to set out points for the solar plant construction site.